So this is question 22, general parentheses. Given n pairs of parentheses where the function general all combinations of well-formed parentheses. For example, given n equals 3, the solution set is this. I think it's very intuitive. A well-formed parentheses means that have an open one and you need to have a matching closed one, whether it's nested like this, or side by side. So a case where this is not allowed. So initially I thought this can be solved using a breadth first search, but I didn't find a very good way to do this. Maybe there is. And after watching some guide online, I think there's also in the solution, I think there's a good way called backtracking. To me, it's very like depth first search like algorithm. So you use recursive calls to form all the parentheses here, and there's a simple template that people can follow. So we firstly give a space for the answer. And we call a backtracking function, which we'll implement later, and then we return as. And it will be a recursive function, so it's return type void. Call backtracking. We'll do the arguments later. So consider a base case when we want to stop, which means we have enough. Like for instance, this is a case where we want to stop. So we need to have. So notice that the length is 6, which is 2 times the open parentheses. Since we need to use the number of open parentheses or the number of n to form this thing here, we can use this n as an indicator to see whether we finish forming all 6 parentheses. So maybe we can call that in n, or yeah, that's fine. And the length, to keep track of this, we want to have something like current string, and we also need to pass in the list. So if equals to n times 2, we want to return and want to add the current string to the answer, which is our string. And there are 2 recursive cases, which is if open is less than n, which means that we are still able to add an open parentheses, and then we do the this open should be also be here, open, and then we'll have close to keep track of the number of open parentheses and close parentheses. Backtracking is current string plus open and n and open plus 1 close. Similarly, if open is less than close, we cannot have this case because we don't allow open to less than close. If close is less than open, the backtracking with closing parentheses still n, and we close plus 1. And we'll do this recursively, or a so-called backtracking method, and then we just need to finish this function call right here. Answer empty string and 0 0. Wait, delete this. let's try this. I think it's a very interesting question. Like, using recursive, you're always going to have less code and to achieve something that's very powerful.